Perfect. So with this, as I said, we will start with the simple times table. This is not an application of Vedic mathematics, but I like to start with my times table with the simple goal, because mathematics tables are the foundation of most of our mathematics. And I have seen often that knowing or not knowing multiplication tables can make or break whatever they're doing. They even love for mathematics, right? If 7 times 8 takes time to them to come to 56, then it becomes a problem for them. So I'm just going to share quickly. I'm not going to take more time, but quickly some ways in which we can teach times table or start teaching times tables to the kids when they start learning times table, which is as early as grade 1 or grade 2, whatever it is. Because what I sometimes see is the kids coming to my class when they are grade 2, grade 3, their parents have taught them, but it's more like a rote method. So if you are at 7 times 7, they have to go 7 times 1, 7 times 2, 7 times 3, right? Like if you don't remember what's 7 times 7, because it's pure memory. So what are the different ways, or how can you give them different tools where they understand times tables better than just something that they have memorized is the idea. But again, as I said, if you guys have come up with a better way or are teaching kids in a different way, we would love to hear about that too. Yeah. Uh, do we need to pause for a tea break, coffee break, water break, anything, or should I start?
You can start.
Okay, perfect. Okay, can we see the multiplication tables? Yeah. Everybody can see it? Gauri, can you see it?
I can see the title only.
Yeah, okay, perfect. Yeah. So what we're going to basically see is the patterns in the multiplication tables. Like these are not just some random numbers that we are asking the kids or what we have memorized over the years. There's a beautiful patterns to this times tables. And we're looking at those patterns today, basically, and also how to combine the math and the art part of it. Yeah, art we are also going to see in the last sessions, but this also starts with simple things. Like if I'm just going to take a simple pattern of 1 is not at all like it's skip counting by 1 is what times table by 1 is, as simple as that. What we're going to do is look at what happens if I put this times table for 1 on a 10-point circle, a circle that has 10 points. And it's obvious why it has 10 points, right? So you create a beautiful pattern by joining these things. When you ask kids to do this, they suddenly get excited about times table. It doesn't become a dreaded affair where they have to. And I've seen kids also to be able to remember the pattern better. I mean, 1 times is very easy for this, but they sometimes remember the pattern to get the answer. So we are giving them basically different tools so that they can remember or understand how these times tables work. Yeah. So when they're doing the times table for 2, we know that it's nothing but skip counting by 2, right? And all we need to tell them is write your numbers 24680, 24680, 000, 11112. And you have the times table. And that's, or it's even number. Show as many patterns as you can to help them remember the times table, to let them not just do a rote memorization. Can they remember 24680, 24680, 0001? Or can they remember skip counting by 2? Can they remember all the even numbers till 20? Do all possible ways for them to remember the times table for 2. And so again, once you do that, how to go ahead and tell them to write it 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. And that's where, because structure is still required, right? We just cannot be in the pattern. We can be. I mean, in the ideal world, we should be in the pattern making world, but in the practical world, we do need to get kids to know this. And this is, again, I'm not saying it in any way takes away the need to memorize the times table. Bottom line is the kids need to know the times table. Only thing what we are doing is we are giving different tools to know their times table, other than the age-old way of just this thing is what we give to them. Here we are trying to give them a 10-point circle. We are trying to give them a pattern. And now when we start with this, what are we going to do? We start with 0, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 12, 14, 16, 18, 20. What are the learnings happening here? You can discuss the shape of this, that this is pentagon. It has 5 sides. This is a learning moment where you are kind of connecting arithmetic and geometry, trying to show that arithmetic, algebra, geometry are not 3 different subjects, but can be connected to each other and linked to each other. We're also asking them to look at the numbers at the ones place here to join it. So there is an additional learning. You can ask them to color this, you can ask them to do this, build in the art so that they also enjoy what they're doing, right? So having done this, now let's go to the times table for 3. 3 and 7 are kind of tricky. Again, I'm just saying they're kind of tricky for a new beginner or an early learner. What is the best? If the kids are smart, again, 3 times 1 is 3, 3 times 2 is 6 is always an option. But this is a beautiful way to tell them how to build your times table by 3. Draw a square 4 by 3. Start from 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Okay. And then 0, 0, 0, 1, 1, 1, 2, 2, 2 and 3. Voila, the times table is done. The second graders and first graders really get excited with this because they really don't know where we are taking them. And it's nice to keep that suspense as to what we're doing, right? Now, once they have done this, now we take them to the structured approach of where they're now looking at this and writing their table of 3 times 1 is 3, 3 times 2 is 6, looking at this and writing their own times table. We are not providing the times table for them, but they are creating their own times table. The idea of Vedic mathematics is making them self-sufficient. We are really not giving them much. We're asking them to create their own learnings for themselves. So now, as I said, go to this part where they are now. This is definitely going to be their to-go place. But again, if by chance somebody asks somebody, and like, you know, second graders 3 times 7, and they forget what to do, they always, and they remember this is going to be easy for them, right? 7, 8, 9, and all I had to do was write 0, 0, 0, 1, 1, 1, 2, 2, 2, and I know my answer. The 3 times 9 is 27, 3 times 6 is 18. It's easier. And I mean, I'm not again saying, again, that's what I'm saying is, yes, they have to do this, but this is again a tool for them, one more tool to remember it. How does the pattern for timetable look like? 0 to 3. At this point, you can also kind of just pause and tell them to imagine, to visualize, what will this look like? If I'm taking from 3 to 6, 6 to 9, what is the pattern that's going to come? Try not to give the answers as much as we can and as much as we are inclined to in other math classes. Pause it every time. Let them come up with their own thinking. So 0 to 3, 3 to 6, 6 to 9, 9 to 12, 14. This is a beautiful pattern. Again, ask them to color, take a minute, tell them how to do it, show them what's happening. That 3 times 1 is, when I do this, 3 times 1 is 3, 3 times 2 is 6, 9, 12. Let them go through it when they say it also. Right? So in case, again, they don't remember the first way, they don't remember the second way, they can at least visualize. Some of them, as we see, are visual learners. They can see the patterns and kind of make it out. Yeah. With this, we go to the 4 times table. Again, make them write their even numbers or skip counting by 2. And ask them to scratch out the alternate digits or the numbers. And we have the 4 times table. We'll also learn about 4 times or multiply by...
repeat the table of 4?
Sorry?
Repeat the table of 4.
Yeah. So again, because kids, I mean, growing up, we never knew how these tables originated or where did they come from. Right here, we are showing them that this is nothing but, again, skip counting by 2, where we are skipping 4 now, right? Because that's the double, right? And later on, we will also see the application of multiplication by 4 or doing multiplication by 4 by doubling methods. Yeah. So now we have the multiplication times table of 4. Again, make them write it, what they have learned there. 4 times 1, 4 times this. They also have this, they have that, and then now we go back to our patterns for tables. Yeah. Again, as I said, pause, let them think. If you have time, make them think. It's not about the time. The time well spent on this part of the education really reaps reward later. You know, don't be in a rush. This is in an ideal world again. 4 to 8, 12, and again a star shape. Yeah. Color, make beautiful patterns. Let them enjoy this part also. 5 times is the easiest one. It skip counting by 5, 5, 0, right? This, I haven't found that the kids having difficulty in skip counting by 5. It's been pretty easy for them. And the times table, the pattern is just 0, 5, 0, 5, 0, 5, 0, 5. So they understand that in the times table, the ones digit, so the units digit is always going to be 5 or 0. There is a learning in each part, even if it looks simple. And that's where we want to, like, can 5 times 6 be 31? No, because I'm only joining 5 and 0 when I do the pattern. It can never be 31. It has to be 5 or 0, right? Now, 6 times table is also kind of little tricky, but you can again extrapolate it or bring it from the skip counting by 3 and let go of the alternate digits. Numbers, sorry, not the digits. So you're at each, so again, Vedic mathematics really, or this mathematics, what I'm talking about, since there is no sutra that I'm really applying to this, but I'm relying more on pattern recognitions and pattern building. Understanding the patterns, that times tables are nothing but patterns of numbers, which make really artistic patterns also in the art sense, right? So going back to your times table of 6, 3, 9, 36, 42, 49, 54, and then now we are coming back to something very interesting, right? What do we see? We see now the patterns being repeated, right? This was the same pattern for which table? If we go back, can anybody think about what was the table which had the same pattern? 3 times, 4 times, 5 times? No. This was the same pattern for 4 times table, right?
Yeah, it was 4, 4.
4 times table.
Yeah, 4, yeah.
Yeah. So now what are we talking about? And why 6 times table and 4 times table having the same pattern? Number partners of 10. An opportunity for talking about number partners of 10, right? 6 plus 4 equal to 10. They follow the same pattern in the other way. So much learning at every stage. 7 times table, 987 653 0 0 0 0 1 2 2 3 4 5 6 7 8. 7 times table is really loved by first graders and second graders to create it this way. 987 654 3 2 1 and 0.
Can you repeat how we start this table?
Oh yeah, sure.
From the beginning.
Yeah. So you again draw a grid of 4 by 3. Yeah. You start writing your numbers backwards. 987 654 3 2 1 and 0.
987 6.
And then you write 0 1 2 2 3 4 4 5 6 and 7. Yeah.
Okay.
And this is your 7 times table. Again, through this, they will, again, I'm showing you this, but what you are asking them to do is, so your activity with them is, first draw a 4 by 3 grid, write your numbers 987 654, they're writing it, then tell them to do 0 1 2 2 3 4. Once they have done this, ask them now to do 7 times 1 is equal to 7. They are building this. You are really not giving them anything.
Exactly.
Just trying to show them the beautiful pattern, right? And then they complete this 7 times table. You can give them a grid. If you want them, you can just give them this empty grids or something. But even don't give them grids. You know, let them write it. Let them draw it. Let them understand what they're doing. That's very important. Spending this time with them. What would be the pattern for times table replicate? That's the question we can ask them. There is, it's going to be same as 3, right? Because of the number partner of 10. Right?
Exactly.
So connections. Nothing is random in mathematics. Times table for 8. 8 6 4 2 0. Now you're writing the even numbers backwards. So again, you're talking about even numbers and telling them how to count them backwards. Draw a grid of 5 by 2. Write your even numbers in both the rows. So this is your activity with them. So you're going to tell them, let's draw a grid of 5 by 2. That itself is a learning. Then you're going to tell them, write your even numbers backwards in the top row and the bottom row. Once they have written that, then you're going to tell them, write 0 1 2 3 4 4 5 6 7 8. So things are happening in sequence. At each point of time, pause, give them time to understand, because kids also struggle with drawing a 5 by 2 grid. Right? We are teaching them what this 5 by 2 grid means. It may be, I mean, we could just say that, okay, draw a table with 5 columns and 2 rows. This, everything is a learning for them. Write your table. And again, this is going to be same as 2.
Exactly.
The other way around, yeah? Again, we're talking about pentagon, we're talking about shapes, we're talking about all the things, regular pentagon. And 9 times 9, most of us know the easiest way to form it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the other, sorry, did I just go fast? Let me just quick. And then, yeah. I'm sure most of us have been doing at least the 9 times table this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm also going to show you a beautiful way if you don't know with your fingers. Now 9 table is going to be the similar as 1 times table. Right? 9 plus 1 is 0. Again, kids are really experimenting in how they connect, and it's so much fun to see. Some of them will go like this, some of them will go like this, some of them will just connect like this. Again, we're experimenting with their own creative abilities, right? Not making math a boring subject is our goal. Yeah. And then our learning here is in one sheet where we are showing that 1 is same as 9, 2 is same as 8, 3 is same as 7, 4 is same as 6. Again, we are not giving it to them. They need to do it. I mean, I know you guys are excellent in creating curriculum, but at every point of time, I keep saying that try to give as little to the kids. And as Prajakti said, it's fun to see when the kids come up with some of the things which we haven't even seen or visualized or thought about before, because every person brings in a knowledge to this learning. Any questions about this times table? I'll just pause for 1 minute. Yeah. Have you been doing it this way at any point? Or have you been doing any of these, or have you been doing any other methods? I would just like to ask you at this point. Yeah.
No.
In Montessori or with your school, Mr. Hassan, have you included any of other patterns or any other tools to teach tables? Which
No. We use traditional way, depending on memorizing, like using cards.
okay.
In order, making as a game for the student. By repetition of using the cards, the student will be able to memorize the tables.
As for us in Montessori, we have tools, special tools to work with multiplication. We have the large bead frame, and we have a lot of tools to work with checkerboard. But usually we focus on the categories, the unit and the tens and the hundred and the thousand in each operation. And then we reach the level where the child will, himself will get the pattern out of this. So he will check, there is a pattern, there is a pattern. So he will say this first word you said, oh, it's a magic.
Yeah.
Yeah.
At the end of the day, these are different tools. Yeah.
Yeah.
Yeah. So again, these are additional tools for you to be used. And again, as we said, we need to give as much as possible to the students so that whoever can take whatever from different tools is what we want at the end of the day, right?
Yeah.
Yeah. So, okay, again, I just put all of these in one. Circle art is fun, math is what we're trying to say. Now, have you heard about stick multiplication? I'm just calling it as plain as stick multiplication, because if you kind of look it on internet, some people call this as Russian multiplication, some call Chinese, some call Japanese. So I really did want to, and I'm simply calling it a stick multiplication. Again, when you are introducing the kids to the concept of multiplication, this is a fun way to use. So we draw the 4 lines, 4 times 3, and you draw the 3 lines and you count the intersection points. So the learning is you also understand the symbol of multiplication. You're understanding what's happening here, what's an array, what's so many learnings here. Again, not an efficient way to do 9 times 8 or something like that, but a beautiful way to start with even kids as young as kindergarten to even experiment with just kind of like 2 times 1, 2 times 3, just making them do. They are drawing and they are counting. Learning is just happening. We may or may not even talk about times table right now, but we can say that 3 times 2 is 6 without even knowing what they're doing. And again, that it's repeated additions, right? So this is another way. Again, for some people it works. Some kids really enjoy this initially and they're excited about it. It's not, again, as I said, 7 times 6, 7 times 9 is not that effective, but to start with with the kindergarten, as young as 4-year-old, 5-year-old, because they know how to draw the lines and they know how to do a single digit additions or counting, sorry. This is another way of doing this. And now I'm going to come to the finger multiplication, where I think I may... has anybody known about this method of finger multiplication? No? Okay. So this multiplication method with fingers is a beautiful method which is called as the peasant multiplication and was used in, again, as I said, the real origin may be Russia, France, or whatever it is, when people knew their times table only till 5. And the traders needed, as they kind of expanded into their trading, they needed times table beyond 5. So what they did was they took the base of 5. So this would become, one finger would become 5 plus 1 is 6, 5 plus 2 is 7, 5 plus 3 is 8, 5 plus 4 is 9, and 5 plus 10 is 10. Unfortunately, we just have 2 hands, and if we have to do 2 numbers multiplication, we need one hand for one and the other hand for the other, right? Let me just 1 minute stop sharing and show how we do it, and then I'll come back to what we're talking about, right? So if you're doing 8 times 7, correct? Now I said we have a base of 5, correct? So my 8 is going to be 6, 7, and 8, right? On one hand, 8. My base is 5, 6, and 7. So now I'm multiplying 8 times 7, correct?
Yes.
Now this is my 8, this is my 7. What do? I add the straight fingers or the unbent fingers. I add them. 3 plus 2 is 5, correct? This becomes my tens. 5 times 10 is 50. And I multiply the unbent fingers. 3 times 2 is 6. So 56. 56. You have your own hands as your calculator when you can do this, and this is so beautiful. The kids really enjoy this. 7 times 7, 5, 6, 7. 5, 6, 7. 2 plus 2, 4. 4 times 10, 40. 3 times 3, 9. 49. 7 times 7 is 49. Right? 9 times 6. Yeah? 4 plus 1 is 5, 50. And 4 times 1 is 4, 54. You're just creating the excitement of seeing our own hands, how, and these can be used for numbers between 6 to 9, right? Because right now you can only expect, or 10, maybe 5 times 5, 10 times 10 also. But this method that I'm talking about can be used for the numbers to multiply between 6 to 9. Now, immediate next question as a trainer, as a student, as a teacher would be, what do you do if you have to do more, right? These multiplications can be done in the groups of 5. You have another slightly variation to do between 11 to 15. Another is 16 to 20. Now, that's where we encourage kids, elder kids now. We are talking about elder kids, grade 7, grade 8, who are in algebra, to kind of see, can they find the patterns if I have to do 21 times 24, between 21? What's the algebraic proof? Can I prove it? What is it happening? Why is it happening? To the young kids, this is important. To the elder kids, why is it happening and how is it happening? Go beyond that and understand that. Is this method kind of making sense? So I'm going to show the this, as I said. Yeah. Again, the fingers, how you show is an entirely different topic, where finger counting is also culturally represented. People in Europe will do the thumb first when they show one. In North America or somewhere, they may do the first finger. In India, we also do using the small bits, like we can count 12 on one finger and 12 on the other hand. And so if you have to calculate 8 times 7, sum of the raised fingers is 3 plus 2, 5, 56. Yeah. So we can try different ones. Do you want to try, some of you? Yeah. Maybe 6 times 7. Anyone?
6 times 7.
Yes, Miss Anaya. 6 times.
I'm trying.
6 times 7. Okay, correct.
6 times 7. So
Correct.
it's
2 plus 1.
30.
Hmm.
And
3 times 4 is 12, right? 30 plus 12 is 42, right?
Yeah, the second step, I couldn't get it.
Okay. So 2 plus 1 is 3, correct?
Yes. So this is the 30. This is the 10.
This is 30. And what are your bent fingers? On one hand, you have 4.
Yeah.
And the other hand, you have 3, right?
Yes, 3 and 4. Yeah.
4 times 3. So the bent fingers, you're going to multiply.
Okay. 3 times 4 is 12.
30 plus 12 is 42.
Okay.
Yeah. So the idea is you know your times table till 5 when you're doing this, but you don't know your times table beyond 5. And so we are just using, again, these are not to be used lifelong. These are just a tool to remember things. Again, if I forget 8 times 8, if I know it, I'm going to do 3 plus 3 is 6, 60. And 2 times 2 is 4, 64, correct? And you get a little more efficient with this. 3 plus 3 is 6, 64, correct?
Okay, yeah. I get it.
So you don't need your calculators. You don't need those questions. What happens if you are up in the mountain and there is no Wi-Fi or there is no calculator? You have your fingers all the time with you to use it, right? Most of us have it. So that's the different ways of doing times table. And I'm sure most of us know 9 times table. Do we know with times with your fingers? So 9 times 1 is 9. You bent one finger, yeah? 9 times 2 is 1 and 8, 18, 27, 36, 54, 45, 54, 63, 72, 81, 90. So 9 times table always, 9 is a beautiful number which lends itself to such beautiful patterns. With this, I finish my times table.